Incomplete dominance is a pattern of inheritance characterized by the formation of a trait that is in between the phenotypes of the parents. This inheritance is exhibited by the 4 o'clock plant. A cross between the pure red and white flowered 4 o'clock plant will produce all pink flowers. The dominant and recessive traits blend, resulting the third phenotype something in middle. In incomplete dominance, there is an absence of the expression of complete dominance. It is very common in the expression of flower color in most plants. Let us solve this problem. Show the cross between two pink 4 o'clock flowers using a Punnett square. Determine the genotypic and phenotypic ratio. Here, we are going to cross heterozygous pink with capital R W alleles to another heterozygous pink 4 o'clock flower. First, let us create grids. Place the alleles in the upper grids and the other alleles on the left side grids. Now, bring the R allele down into 2 grids, as well as the W allele. Then, spread the alleles on the left side across the grids. Calculate the genotypic ratio or the genetic makeup of 4 o'clock flowers by counting the form alleles. There are 2 heterozygous capital RW alleles, 1 homozygous capital RR alleles, and 1 homozygous capital WW alleles. So, the ratio is 2 to 1 to 1, or we can express it as a percentage where each grid is equivalent to 25%. Since there are 2 capital RW alleles, there are 50% RW, 1 capital RR alleles or 25% RR, and 1 capital WW alleles or 25% WW. Finally, let's determine the phenotypic ratio or the traits that would show up. Since 2 capital RW alleles correspond to 2 heterozygous pink flowers, 1 capital RR alleles correspond to 1 homozygous red flower, and 1 capital WW alleles correspond to 1 homozygous white flower. The ratio is 2 to 1 to 1, or 50% pink, 25% red, and 25% white.